Okay, make sure you go and read the example 6, resultant force, and use your right hand rules, R cross F. Resultant for metals, for moment, R cross F. And the location of this one depend, this one depend on where you want to put. Anywhere you want to put also okay, but as long as you take R cross F. And we introduce you the metric system to do it. So you write I, J, K, then the R, F, 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 X, Y, Z, X, Y, Z. Okay, so if you have one set, you do this one. If you have two set, you need to repeat two times, like what you see on the example 6. Okay. And then you do the operation. Remember to write unit as your final answer in the final answer with the bracket and then unit. Okay. We try to conclude chapter 3 today. We still have a few, maybe 3 more things to learn. Okay, so moment of a force about a specific axis. Now we try to move our forces to somewhere and we'll create a moment. So for example, the one that you see on the screen here, when you want to remove your tire, to replace with a spare tire when your tire is punctured, right? So you put in the screwdriver, all right, the L bar. Then you try to turn, all right? You try to turn. You try to press down, not press. You try to pull force up with a perpendicular distance, perpendicular direction. So the L bar will rotate anti-clockwise, right? So with your right hand rules, if you rotate anti-clockwise, your axis will be here. You will create, this force will create moment at y-axis. So if in 3D dimension, remember to draw your axis x, y, and z. So if you turn at that point, for example, O, your axis will be pointing towards y with your thumb by using right hand rules. Okay, then there is a D. There's a D from here to here. Right. But make sure this D is 90 degree. So you need a D over here, right? Okay, F multiplied by D. This is the distance you need to get the distance. Okay. So this my is this L bar, this the one that go outside. However, for the moment axis. Okay. So for this case, the nut can only rotate in the y-axis, right? Y-axis. So this is just to introduce you another 2 axes. So we'll do scalar and vector analysis. There are 2 methods to identify. So scalar method is F multiply D. If it's vector analysis, then you need to use R cross F with the matrix operation. Okay, so scalar analysis, you take my equal to F multiplied by D. Both must be perpendicular. You can split your force perpendicular or maintain D, or you can maintain F and then split your D into 90 degree to the F. As long as these two are perpendicular to each other. Okay, so just need to be careful on the calculation. Only one of it need to be perpendicular. Don't split 2. If you split 2, then in different direction already. Okay. And from this diagram, we need this distance, f multiplied by perpendicular distance, we did this one, d. Your dy is d cos theta, right? This one, this distance, d cos theta. If you're weak in tan sine cos, please work hard a little bit. Please work hard a little bit. Okay. The rest you read. So if you want to calculate moment, remember, if you change the location of the moment, the calculation will be different already. So for example, you have 5 nut on the diagram here. You change your location of the nut, the D will be changed. If you move this L bar into different location, the calculation when you write, please write carefully. If you are referring to A, then you write A. If you're referring to B, write B. Okay. So if you write A, make sure you go to your diagram and label where is your A. So if your calculation, you write my, then you have to have y in your diagram. Okay. The rest you read. Forces do not create moment about the axis if it's parallel to the this one is, you know, when it's parallel, it's nothing. Okay. It means that if the force go this way, if the force we put along this axis, it won't create moment. We're just pulling out the L bar. Okay. Okay, vector analysis, you'll see the differences when you need. Scalar method is quite direct. Scalar method usually will be in a 2D form. But if sometimes the question force you to use vector analysis, then no choice, you have to break into X, Y, Z axis. And usually 3-dimensional, you need vector analysis. So X, Y, Z, you split your force from the origin. There is a R. Okay. You need the R to calculate the U unit direction. Okay. So the same methods, if it's around O, you take R cross F, Y, my, and all this. So these are the thing that you learned from the previous chapter. It's just on the application today. Okay. So if you want to determine moment from O, you write MO equal to R cross F. And this one, if you use vector analysis, you are calculating the vector. You are calculating the vector. Okay. So the rest you read, you already know from previous one. So my equal to direction, magnitude and direction. Okay. So direction is J. If you use right hand rules, pointing to the y-axis. The magnitude is R cross F. R cross F. So you can expand this one, this line, this R line, expand the tail of the force. You will cross the R cross F. Okay. So this is on the application. So we go a little bit on the theory. Let's say you have a force at any point of the object from a point A, and you want to focus on any point along the axis of the object. Let's say we pick O. So you can calculate the moment of O with R cross F. R, then you extend this one, R cross F. Okay, UA is a vector unit. This is the direction of the vector. Okay, this one you know. Moment equal to R cross F at O. something new for today. Not new lah. Previous slides, you will see projection of force. Today, you learn projection of moment. Previous chapter, you learn about projection, means you split your forces on the axis, to the axis. But now, we split your projection of moment to another axis, two axis. So this one, if we split your moment into A, mean this is a moment at O, and you want to split the moment into two axes. One is one is A direction. One is perpendicular direction here. Okay. Then you write UA multiplied by the magnitude of the moment. R cross F, you get magnitude. So this is called triple products. Triple products. So this is one. R cross F is one product, and multiply like this one. So you have three vectors here. Okay. So for starting today, you learn about projection. You force your moment onto an axis. Okay. So most of the time, we will split the moment. Once you get a moment at A, we'll split into X, Y, and X, like what you did for your moment, but we use dot products and cross product together. Okay. So if you want to write moment A with this formula, MA equal to unit direction A dot bracket R cross F. So you write in the vector form, UA you have IJK, UA you have IJK, UAX, UAY, UAZ, this one become 1. Dot R cross F, this one, you already expert already, so you convert cross into matrix form, IJK, R and F, and you do multiplication. Okay, so you do multiplication, then you group IJK in one more time. Okay, this one, I dot I, you get 1. I dot J equal, okay, dot product. Don't confuse between dot and cross. I dot I, you get 1. I multiply by not, if the vector is not by itself, you get 0. I dot K, I dot J, doesn't matter. You get 0. Cross I, you get 0. And you remember the circle I, J, K, anti-clockwise positive, clockwise negative. Sorry. Anti-clockwise positive, clockwise negative. Okay, so you do the calculation accordingly. So you arrive at new equation. So for example, how you get Ry Fz minus Rz Fy, you put your finger on the I, you're calculating the I. So you take Ry multiply Fz minus Rz Fy, you get I. So the term of I in the second bracket here, matrix matter, I multiply I, you get UAX bracket, the product of the matrix. You repeat the same for J and K. Just remember, for the second one, your J will get negative because you are clockwise direction. K will get positive because you are anti-clockwise direction. Okay. And so on. Okay, so in this case, we just use positive at the moment. But important is the first line here, this one. The rest is just elaboration. Okay, then you put all the terms here as this one. Okay, all the terms here, this one. So today you learn a new matrix for moment. Moment A equal a new bracket. So this one, if you want to do projection, you split your moment into one of the axes. What you do, U, R, and F. you change your IJK in the matrix into U, UX, UY, UZ, RX, RY, RZ, FX, FY, FZ. Okay. I think if you really want to calculate, I think this one is negative. Okay, what else? Okay, so I think this one is the one that you need to take note. If you want to do projection on the axis, then you use this matrix to expand into this equation. Okay. In exam, maybe you forget this second line is okay. You can straight away use this formula. Okay. If you're hardworking, you can write write the second one and the third one. But if you straight away you write matrix, also correct. Okay. So yeah, this is the thing. So if you want to do in exam, you want to do projection, please write this presentation. Right, projection on what axis? MA. In this case, you project to the A axis. Equal, write this one. MA equal to UA dot bracket R cross F equal, and then write this equation. Then only you substitute value in. Okay, write this equation, then only the second line of your answer, then only you substitute value in. Don't straight away substitute, because if you substitute wrong, then the rest is wrong. Okay. So this equation is important. Okay, the rest is important. And this one is dot products. This one is dot products. So you see in the diagram here, the second 90-degree moment here, we use dot or dash because we only get value when two vector go parallel. In the dot products, this one, you only get value when two vector go parallel. When in the dot products, you know that dot products A dot B equal to AB what? Cos theta. So what happened when you theta equal 90 degree? 0, right? So when you multiply 0, you get 0. Okay, so when you do projection under cross products, you only need to focus on the one that you project parallel. This formula have to always remember is always parallel to the axis that you want to calculate. Okay, so don't use the 90 degree. So don't confuse with the dot and cross again. If you're not sure, go back to the previous slides. Go and compare side by side. What is dot, what is cross? Yeah, concept is can say 180 different. Okay. So yeah, just take note. So that's why this diagram, you see the 90-degree moment vector, we use the dot line because it doesn't create any moment at that direction. Okay. Okay, so you can write the vector analysis if you combine this one you get the magnitude. R cross F, you get magnitude with this MA. UA is a vector, so you put back the UA. Okay, so same, just remind, force also same. Vector force equal to force U vector, same. Now we just learn about moment. So let's see how we apply in the question. Determine the resultant moment of the three forces in the photo or in the figure. About x-axis, y-axis, z-axis. This is just a more on application. Ignore this red color statement first. So we have three forces in the diagram. We have force 1, force 2, force 3, F1, F2, F3. In this case, again, this kind of question apply only in tutorial question. In a test or final exam, the forces all will have angle towards a certain point. There will be angle. I will flip this arrow up at a certain angle. Okay, so this is just for illustration only. Okay, so all the diagram will have a dimension from one of the point. In this case, you know that the question force you to focus on point O, because all the dimension go from O. So O to point C, 0.6, O to this corner, 0.6, then A from the O, Z direction, 0.6. This corner is 0.9 meter. Okay, so you label your diagram accordingly, A, B, C. The hand is just a tools for you. In exam, you won't see hand inside the diagram. Okay, hand is just tell you that, oh, this is y-axis moment by using right hand rules. Okay, if you want to calculate x, is this direction, right? Right hand rules. Z also same, right hand rules. In exam, you won't see hand. You won't see the hand in the diagram. Okay, we want to find the resultant moment. Means we have this equation. This equation. You write, you write this equation. Sorry, not this one. You write the earlier equation, which is MO equal to sum of R cross F. This you have three forces. Right. So now you focus on O. This question didn't tell you where to focus on, because you can put moment at any corner or any place inside the object. However, in the question, they already give you very clear dimension. If you shift around, if you didn't use O, you use any location can. You make the calculation a bit complex. You need to calculate the location to that point that you choose. Okay. Okay, so in this one is the highlight what happened when the force is parallel to the coordinate axis, right? So parallel, you have something and you have or has a line of action pass through the axis does not produce moment or turning about the axis, right? So this is just explaining this line. Okay. Okay. So for x, this one for x, F1 generating force, generating moment, because it's this direction, right? So you x, yeah, like this. Okay. So your force, you take F1 multiply by the distance, perpendicular distance, 0.6. You get the first moment about x. Right. Second one, 0.5 over here. So here, perpendicular distance is 0.6 also. Sorry, this one F1 0.6. F2 will be 0.6. Two 50 on that. 1.6. 300. P oh, okay. P is on this corner. The distance will be 0.6 meter from this line, x-axis, and it's positive. Okay. So B, this one is at this corner. So you can extend the line of F2, go down. It will intersect with 0.6 line here at another corner, right? 0.6. And then it will try to turn the axis. If you stand at x-axis, you look in from this direction, you will see F2 will turn anticlockwise. Okay, if you stand at x-axis, it will turn anticlockwise. So that's why positive. So here, if you stand at x, you look for F1. You look for F1. F1 will try to turn anticlockwise also. Okay, if you view from x, then your thumb will be pointing your face. Okay, your thumb will be pointing your face. This is the tell you where is positive direction. Okay, then what happened to 3? 3, if the force go parallel with your line of eyesight, go parallel, it do not create any moment. Okay, because this one, no matter how you turn the R, no R, there is no R there, because it's go parallel to the axis. Okay, so this statement is just mention this one. This is what happen if the forces is go parallel to the one that you see. For example, x-axis. You stand at x-axis and then you see the direction of the force. If it's go across, then force got moment. If it go down, got moment. If it go parallel with your eyesight, if you stand at x-axis, go parallel with the axis, it do not generate moment from the x-axis, for the x-axis component. F3 do generate moment for the y and z. Yeah. So by using the understanding of mx, can you write moment for y? Can you write moment for y? If you stand at y, then use the right hand rules. Y at positive pointing towards your face, and you stand at the y-axis. Which one do not generate moment? F1, F2, F3. Which one do not generate moment? F1, F1 do not generate moment. So you will see, so in your answer, you write my equals 0, because F1 go parallel with your eyes. 0 plus, then you go to F2, F2 go like this, right? Go like this, so it will be negative. Right? If you see from Y, F2 will rotate clockwise, so negative. Then what else? Sorry, F3 will be negative. F2 will, it will swing down like this. It will clockwise also, so it will be negative. Okay, so this one, F2, 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 F2 should be negative. This one should be negative. F3 multiply by 0.6. F3 multiply by 0.6 here. It will rotate clockwise. So this one should be negative. Should be. Okay. F2 and the clockwise, so negative. F3, yeah, F3 is clockwise, so it should be negative. Okay, should be negative. Okay, the resultant not resultant, the total moment at Y will be negative something. Z also same. If you see from Z, use right hand rules. F2 now becomes 0, because you look down. So Z, if you go Z, the F2 go parallel with your eyesight. So F2 didn't generate anything. So when you look down, F1 will rotate. What's the direction of F1? F1. Okay. F1 will rotate 0.6. F1 multiply 0.6. No, F2. F1. Okay. F1 because it go along the axis, no R. The F dot D is 0. This go along the y-axis. So the D is 0. If F1 shift a little bit towards X, then got moment. But F1 is go along the y-axis. So if you're seeing from Z, it's just like this. So there's no rotation. It go into the axis. Right? If you see Z, CZ is like this. Okay, F1 go like this. If it shift up, then got moment. It will turn like this. But now F1 is along the y-axis. So 0. Okay. Then the third one is R3, 200 multiplied by 0.6. You see, you rotate 200 multiply 0.6. Okay, so just highlight this one in your notes for F1 and F2. F1 0 because F1 F1 sit on the y-axis line. Just take note on this one. Okay, then you get a negative. Okay, why negative? And yeah, correct. This one should be negative. It should be negative 200 bracket 0.6 because F3 is clockwise. Okay, yeah.
So if F3 was along the x-axis, then it won't have a moment as well.
If this one, F3, sit on here,
yeah,
it will be 0.
Also be 0.
Yeah, because you didn't see anything, it will not move. It's just pushing the point. It's just pushing. It do not rotate that point. Okay, it's like you're tying a rope to that force, and then what do you feel? Like swinging the thing. Okay. So take note, this one. The notation on my slide is there's a typo error there. Okay. Okay. We apply a bit more. Example 8. So determine the moment of AB. So you have a U shape of bar. So AB will be here, and then you are pinned down with a round collar at point B and maybe point A. So this one free to rotate clockwise or anti-clockwise for the member of AB. And there's an L shape above the A and to C. So he asks you determine the moment of AB produced by the force F. So force F pushing down along z-axis. Okay, so again, example 8 is very simplified question in test or exam. The force will tilted at a certain angle. So when it tilted certain angle, remember to split your force into X, Y, and Z direction. Okay, so you are given all the dimension, 0.2 to B, 0.4 from B to Y axis, A to the length of L bar, 0.3 from the length of the end of the length A to C will be 0.6. Okay, so C to bottom will be 0.3. Here is 0.3. Okay, it asks you to focus on this line. this location. So meaning at the end, you're focusing your right hand rules put on the AB member. Okay, you can put on your AB member. So if you're seeing from this direction, AB direction, so your direction is anti-clockwise like that. Anything that go against this one will be negative. Okay, so if you want to solve this question, what do? You need to draw this diagram by using vector analysis. Anything that is in 3D, the next step, you need to split, you need to notate in the diagram your R, then find U, then write the vector for the force. This will be the procedure. Okay, so this one, we focus on A to B. So A to B, there's a direction there. We label as UB. Why we need UB? Because the question asks you moment of AB equal what? Equal to U, not U, U, we have two lah, AB equal to matrix of U cross, not cross, dot, R cross F. Okay, so if you see a vector that is not on the axis, you need to use this formula, M equal to U dot bracket R cross F, because you will project the vector onto the axis. Means, or another meaning means you force the F reaction onto the member of AB. And you see the green color circle, you follow the right hand rules, means all the direction that anti-clockwise along the AB member will be positive. And UB positive along A to B direction. Okay, so from the left hand side diagram, you need to draw the new diagram in your answer sheet by labeling A, B, C, and then put in where is your moment at moment AB. So for example, the question asks you to find the moment AB. Your diagram need to show me where is the moment of AB. Without diagram, maybe half of the question gone already lah. Okay, your diagram usually 8 to 10 marks for one question. If you do not include diagram, minimum you lose 8 marks, minimum. Okay, remember to label things that you calculate. Then this one is from the A. Your A is the connecting point, and it's also the center of the three axes, X, Y, and Z. Because in this diagram, you can pick any point you like. You can put B if you want. But in this case, you already given the origin of X, Y, Z. So use that point as your starting point for calculation. So in this case, we use A. And then A towards C. A towards C, you have a direction vector RC. You should be able to write vector RC. Vector RC, you have IJK also. Means how many steps you walk from A to C in X. How many steps you write from you walk from A to C in Y direction. How many steps you write A to C in Z direction. With the curly bracket IJK. Okay. Then A to D also same. A to D. Okay, so here you see in the diagram there's no D. However, we need the point of D in our calculation. R to D means the intersect of your force to the x-axis. So RD is a newly developed or new add-in point. So RD also same. RD you need to write in vector form, curly bracket, IJK. How many steps you write? You walk in X. How many steps you walk in Y? How many steps you walk in Z? So for example, RD equal to 0.4 meter I plus 0J plus 0K. If RD, RD you walk 0.4, 0.4, not 0.4, 0.6, correction. You walk 0.6x, or means 0.6I plus 0J plus 0K. However, for RC is 0.6I plus 0y or 0j plus 0.3k for RC. You need the R to calculate U. How to calculate U? You take the direction, the vector R divided by magnitude R, you get U. Okay. So you write this equation first. MA equal to UA dot R cross F equal this matrix. You write this equation first. Then only you modify the sub here. Or you can straight away write the sub if you want. So in this case, we will write in AB form. And if you don't want to write this one also can. You just modify the A, the sub A into AB. Because the question asks you AB. Okay. Then the rest is calculate lah. So UB is this direction. UB equal to RB divided by the magnitude of RB. So RB is here. RB vector will be 0.4I, curly bracket 0.4I, 0J, 0, no, not J, 0.2J, and 0K. So you do the magnitude square I square Z, square your X, Y, Z, square root, get the answer, right? Okay. In your calculation, if you don't put in the unit, I still give you correct. Only I focus on the final answer. Okay. So at the end, you find your UB equal to something I, something J. Try to understand the steps. The value will change in the exam. So once you find your J, so the rest you read lah. So vector R directed from any point AB to any point in line. Position is okay. So you have two position. You have RC and RD. Then you can use RBC, RBD also, if you want. Okay. In this here means toward force. Force you need the R from A. Okay. This equation you can use any R multiplied to the force. So as long as the force is here, you can use any R connecting this force to the A. Right? You can use RC, RD, RBD, RBC also. RBC, this means you are looking at B point. If you use RBC, RB to C. So in this case, we were just looking at RC or RD. You choose one. Both also correct. Both also correct moment. Okay. The focus here is focus on F. Then any distance from this member, because the question asks you along this member. So your R can be here, 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 here. Any distance from along the member. R can be from A in the body of AB, any member until B. It can be R distance from to the member of AB. Any R distance. Okay. BD is from B. Just now is forces to A. BD is from here, here. Because your force can pull down from until here. So your BD also apply. Okay, so we'll choose only one because other R also arrive at the same answer. We only choose one that is more simple. We choose RD because it's lay on the x-axis. Lay on the x-axis, your y or your j gone, your k also gone. So only finding x or I vector. Okay, so you already only very simplified. You only have 0.6i. Other you have I, j, k value. So you substitute the force. The force, remember to change into vector form. Go down in k direction, in negative because your z positive go up. This will be the careless mistakes. So take note in your revision note. Be careful on the direction. Go down, negative. So from here, you substitute inside this matrix form. Okay. So how you write the matrix form R cross F here? You have R cross F with I, J, K, Rx, Ry, Rz, Fx, Fy, Fz. So you substitute this one 0, this one 0.600, Fx 0, Fy 0, Fz minus 300. So this one will give you what? You arrive at Ijk. So you cross I, 0, 0. You cross J. This is how you do modulus, right? R cross F. No, this is the format to calculate Ijk. Yeah, you only have two for matrix R cross F. This is from here. We are looking at this matrix, green yellow color matrix. Okay, so you put in the value, you will get this. You'll get something like this. You can put inside here, or you straight away put in the projection matrix. This one is a complete one. You put in URF for the moment. The one I write on the whiteboard here is only for the cross products. Okay, only for the cross products. If you use U dot the moment, it means you project to one of the axes. Okay. In this case, we project on the RD. You use UB cross to this direction. Okay. Okay. Then you will get, you solve 3 by 3 matrix. Okay. So if this one is your homework lah, if you don't know how to do 3 times 3 matrix, go home and watch YouTube lah. There are lots of video on the how to find 3 by 3 matrix. Okay, we assume we already know. Okay, so at the end you get one answer. Okay, so if you get positive, it means something. So for this module, once you get answer, you need to tell me where is the direction, where it turns. So here, if you get positive, so you write the sense of MAB is in the same direction of UB. With this one. This moment is on here. But if you already draw the diagram, then you don't need to say this one. Just in case you didn't draw, you need to write this one. If your diagram you already draw everything, then you just You just stop here, stop it, maybe. Okay, then you combine the two, express in a Cartesian vector. So MA, you define this is a magnitude, 80.5 Newton meter. UB is this one. Okay. Yeah. You cross, you get scalar number. Then you dot also. If you calculate, UB dot that one, you also get scalar magnitude. Okay, so this one you multiply, this one multiply inside. The rest you read. If AB defined using unit. Okay, so it's from B towards A, then different already. This one is from A to B. If you look from B to A, then your UB flip direction, you'll get negative here. If you flip, because you are looking at vector. Vector in direction is important. Okay. So if you look from B to A, then your answer will be negative. Same magnitude, but different notation. It become negative value. Yeah. So it's important you mention where you're from. Okay. Example 9, I treat as your homework. Go and see this example 9. A lengthy procedure. Go and read. This one is in test or final exam format. You will see something like this, not as example 7. So this one will be as the complexity will be the same as your test 1 and final exam. Okay. So meaning if you're weak in matrix, go home and read the matrix method. If you're weak in 3 times 3 matrix, go home and do practice on the matrix. Okay, this one you read, all the answer is there. Okay, so we have a short break. We'll continue 9:05. We'll go into moment of couple.